Pytorch commands. Device management. Check GPU availability. Import torch. Print torch, CUDA, is available returns true if a GPU is available. Otherwise false. Set device. Device torch, device CUDA if torch, CUDA, is available else CPU. Print device outputs either CUDA or CPU. Move tensor to device. Tensor torch. RANDN3. 3. To device move tensor to the specified device. Move model to device. Class simple NN. Module. Def in itself. Input size. Hidden size. Num classes. Super simple NN. Self. Init. Self. FC1 NN. Linear input size. Hidden size. Self. ReLU NN. ReLU. Self. FC2 NN. Linear hidden size. Num classes. Def forward self. X. Out self. FC1X. Out self. ReLU out. Out self. FC2 out. Return out. Model simple input size 4. Hidden size 10. Num classes 3. To device move model to the specified device. Check number of GPUs. NUNCPUS torch. CUDA. Device count. Print F number of available GPUs NUNCPUS. Get GPUNAM. If torch, CUDA, is available. GPU name torch, CUDA, get device name 0. Print F GPU name. Move data parallel. If torch, CUDA, device count 1. Model NN, data parallel model. Model, to device move model to the specified device. Sparse tensors. Create sparse tensor. Import torch. Indices torch. Tensor 0. 1. 1. 2. 0. 2. Values torch. Tensor 3. 4. 5. D-type torch. Float 32. Sparse tensor torch. Sparse tensor indices. Values. Size 3. 3. Print sparse tensor. Todense converts sparse tensor to dense tensor. Quantization. Quantize model. Import torch. From TorchVision import models. Models. ResNet 18 pre-trained true. Model. Eval. Quantized model torch. Quantization. Quantized dynamic model. Torch. NN. Conv2D. Torch. NN. Linear. D-type torch. Keyed 8. Print quantized model. Quantized tensor. Import torch. X torch. RANDN 5. 5. Quantized X torch. Quantize epitensors. Scale 0.1. 0.4. D-type torch. Keyed 8. Print quantized X. Dequantize convert quantized tensor back to float tensor. Linalg operations. Matrix operations. Import torch. Matrix multiplication. A torch. RANDN 3. 4. B torch. RANDN 4. 5. C torch. Matmula. B. Print C. Matrix inverse. D torch. RANDN 3. 3. DINV torch. Inversed. Print D in V. Eigenvalue the composition. Import torch. Eigenvalue decomposition. A torch. RANDN 4. 4. Eigenvalues. Eigenvectors torch. EIGE. Eigenvectors true. Print eigenvalues. Print eigenvectors. Probability distributions. Normal distributions ampling. Import torch. Sampling from a normal distribution. Mean torch. Tensor 0.0. STD torch. Tensor 1.0. Samples torch. Normal mean. STD. Print samples. Categorical distributions ampling. Import torch. Sampling from a categorical distribution. Probes torch. Tensor 0.1. 0.4. 0.5. Samples torch. Multinomial probes. numsamples 1. Print samples. Gradients. Compute gradients. Import torch. Xtorch. Tensor 1.0. Requires grad true. Yx2. Y. Backward. Print x. Grad print gradient of yw. R. T. X. Disable gradients. Import torch. Xtorch. Tensor 1.0. Requires grad true. With torch, no grad. Yx2. Printy. Requires grad outputs false. Since gradients were disabled. Grad accumulation. Import torch. Xtorch. Tensor 1.0. Requires grad true. Yx2. Y. Backward. Print x. Grad outputs gradient of yw. R. T. X. Yx3. Y. Backward. Print x. Grad outputs accumulated gradients of yw. R. T. X.